Hey, this is Mr. Hansen. I wanted to work through an interesting proof with you about isosceles triangles, and that is that their base angles are always going to be congruent no matter the isosceles triangle. And this isn't proven formally very often because we can just think of it as a reflection and show that angle B is equal to angle C, but I'd like to give a little bit more of a formal proof today. And one of the reasons for doing this is to help you see how you can bring things into a proof, add things to your diagram to help you understand how the parts of your diagram work. So I'm going to go ahead and start. Sorry about that, I just lost a piece of my triangle. I'm going to go ahead and start by extending this segment AB. I'm going to extend it out to here and call that endpoint E. And I'm going to, if I had a compass, I could copy BE right over to here. So I'm going to extend this out. And that's going to be, we'll call that D. And then I'm going to connect these two line segments. And we know that BE is congruent to CD because we just constructed it. So you could take a compass and measure BE, and then you could take a compass and measure CD to make sure that they're congruent, and they're also just an extension of AC and AB, so they're on the same line there. Okay, now that we have that, let's just put some of our information in here. We know, first of all, that this AB and AC are congruent because it's an isosceles triangle. That's given information. And we know that BE is congruent to CD. Well, we just constructed that. So there's some information. And let's take a good look at what this tells us right here. It looks like we have some proportionality going on in this particular triangle. So you could say AB over BE, and I'm just going to sketch that out here. AB over BE equals AC over CD, because these parts, well, it's the same thing. AB is the same thing as AC, and BE is the same thing as CD. So if these are proportional, we know a little bit of something about these two lines here. They have to be parallel. It's kind of a converse theorem. If you have proportional segments of lines in a triangle like this, then the lines are parallel. So we know those are parallel, so I'm going to just kind of put in a little triangle there, and let's do it in a different color so you can see it a little better. A little triangle there and a little triangle there to say that they're parallel. Okay, let's take a look at maybe one more thing. I've got, oops, let's try it again. Maybe erase the last little part here. I've got from B to D and from C to E. These are diagonals of a quadrilateral. Well, what kind of quadrilateral are we speaking about here? If we have a pair of parallel lines and the opposite sides are congruent, we're talking about an isosceles trapezoid. And if you know it's an isosceles trapezoid, then one of the properties of an isosceles trapezoid is that those diagonals are going to be congruent to each other. So BD is going to be congruent to CE because you have an isosceles trapezoid. I'm just going to write that one down here. BD is going to be congruent to EC. Okay, so now we're going to take a look at some little triangles here. I'm going to kind of highlight them. I want to highlight it in blue. So here, looking at that triangle. And let's highlight the other one in green. We're comparing it to this triangle here. Hopefully you can see which two I'm talking about. So are those two triangles congruent? Well, you know the diagonals are congruent, and you know BE and CD are congruent, and you also know BC is congruent to itself. So we could say through the side, we know that the triangles are congruent. So once you know that, think about this angle right here and that angle right there. They should be congruent to each other because they're corresponding parts of congruent triangles. Now we have almost completed the proof. One last thing to think about is the supplements of these two angles. If these two angles are congruent, then they're going to have congruent supplements, and here are the supplements right here in black, right there and right there. So angle C must be congruent to angle B. I know I didn't take the time to write all of this out because I feel like it may get a little bit more complicated than it's worth, and I hope walking through it and talking through it helps you to kind of understand and get a greater appreciation for why isosceles triangles have congruent base angles. My other purpose was to help you understand that you can add things to your diagram to help you understand some things that are going on in your diagram. So all of this stuff here, all of that stuff right there, we kind of added to the diagram to help us understand that these two black angles there were congruent. Thank you and have a good day.